Okay, so our next topic is integral calculus. Till now we have discussed about differential calculus. Now we have to talk about integral calculus. So in integral calculus mainly we have to learn about this definite integral. Okay, so suppose if y equals to fx is any continuous function defined in this interval ab such that capital F of x is antiderivative. The meaning of this term antiderivative is simply integral. Okay, integral is also called antiderivative. So if capital F of x is integral of small f of x, then integration a to b fx dx, this will be f of b minus f of a. This thing we know from class 12. Okay, so this is an important result in case of definite integral. Integration a to b fx dx is capital F of b minus capital F of a, where this capital F of x is integral of small f of x. So this is the formula for calculating definite integral. Now there are total 7 different properties of definite integral that we have to learn. So the first property is integration a to b fx dx is same as integration a to b f of t dt, and this property is obvious because see, whether your variable is x or t, ultimately you have to write this lower and upper limit in place of x. So whether this variable is x or t or some other variable y, this will not make any difference. The value of this integral will remain same as long as you have the same function and same lower and upper limit. So this is first property. The second one is integration a to b fx dx is negative of integration b to a fx dx. If you change the limit of integration, then you will get this minus sign. Again, this property is self-explanatory because now this thing will be f of a minus f of b, and with minus sign it will become f of b minus f of a. So this is our second property. These two properties are obvious properties. Now the third one is integration a to b fx dx. This will be integration a to c fx dx plus integration c to b fx dx. Okay, so this is our third property where c is any real number. Okay, this property is valid for any real number c, but generally we use this property where c is a number between a and b. Okay, you can apply this formula for any value of c, this relation will be correct, but generally this is used when the number c is between a and b. And if you know the meaning of this definite integral, then this property will be self-explanatory. Or you can also see from our right hand side. The right hand side will be, suppose if integral of small f of x is capital F of x, so this first term is going to be f of c minus f of a, right? This will be the value of our first integral on right hand side, and the second integral on right hand side, this will be f of b minus f of c. Now as you can see, these two will cancel and this will give us f of b minus f of a, which was nothing but integration a to b fx dx, which was our left hand side. So whatever be the value of c, you can see that these two will always cancel and you will always get this integration a to b fx dx. But generally this is used when the number c is between a and b. So this is one way of looking at it. Another way of looking at this result is, we all know that integration a to b fx dx is nothing but area under this curve. Suppose if you have some curve y equals to f of x, then this line is x equals to a, this line is x equals to b, then this area under the curve between these two vertical lines, x equals to a and x equals to b, above this x-axis is nothing but the value of this definite integral, right? Now suppose if I have some point c in between, say this line is x equals to c, so now this first area will be nothing but the integral given by this first expression a to c fx dx. I can call this area as a1, and this second integral is nothing but area from c to b, so I can call this second region as a2. Now you can easily see that this total area is nothing but sum of these two areas. So So this is another way of looking at this result, that area from A to B will be area from A to C plus C to B. Okay, so this is our third property. Now we will take one example and we'll see when these properties are applied. Okay, how to use these properties. So suppose if I have to evaluate this integral, say the question is find the value of this integral 0 to 4 mod x minus 2 dx. Okay, now here you cannot directly integrate this function as long as you have this modulus sign. So first step will be to get rid of this mod sign. Okay, so we all know that mod x was defined in this manner. Mod x is x if x is positive and minus x if x is negative. So if I want to get rid of mod sign for mod x minus 2, so this will be x minus 2 if x minus 2 is positive, meaning that if x is greater than 2, then mod x minus 2 will be x minus 2, and if x is less than 2, then we will get minus x minus 2. So this is the definition of mod x minus 2. Okay, so as you can see that the value of mod x minus 2 will change. The definition of mod x minus 2 is changing at 2. Before 2 you have this function x minus 2. Sorry, after 2 you have this function x minus 2, and before 2 you have this function. So this means if I want to solve this integral, I have to break this integral at 2. I have to write this as 0 to 2, and then we have to write 2 to 4 mod x minus 2 dx. Right? Now if I want to evaluate this integral, then when x is from 0 to 2, x minus 2 will be negative, and if you want to get rid of this mod sign, you must place a minus sign outside. So our first integral will be this one, plus second integral will be 2 to 4. When x is from 2 to 4, x minus 2 is positive, you can directly remove the mod sign. Okay, so now you can easily integrate this function, right? So if I have to integrate this, now again there is an interesting concept that you can learn which will help you in reducing your calculation mistake. See, if I want to write the integral of x minus 2, then there are two ways of writing this. Integral of x minus 2, either you can write this as x square by 2 minus 2x, or you can also write this as x minus 2 square by 2. Okay, these two are same except for the constant term. So both of these integral are correct. Now here I am going to write the second one, and you will see what is the benefit of that. So x minus 2 square by 2, and we have one minus sign here. So in definite integral, whenever you get minus sign, change the limit of integration. Integral was from 0 to 2, so write this from 2 to 0 to take care of this minus sign, plus x minus 2 square by 2 limit from 2 to 4. Okay, so now you will get, if you place 0 here, then you will get 0 minus 2, so minus 2 square divided by 2, and if you place 2 here, this will give you 0, plus if I place 4 here, I will get 4 minus 2 square by 2. If I place 2 here, I will get 0. So now this will give us 4 by 2, 2, plus 2 square by 2, 2. So this will be 4. Okay, so this means the value of this integral will be, here the answer will be 4 unit. Okay, so in this way that third property is applied here. Since the definition of fx was changing at x equals to 2, so we had to break this integral at 2, 0 to 2 and then 2 to 4. Now there was one question in GATE 2018 based on this third property. Okay, so now the next question that we have to solve is, this is from GATE 2018. If the function fx is defined in this manner, fx is x minus greatest integer of x. Okay, this function is called greatest integer function. This is nothing but greatest integer function, and the meaning of this function is, this function is defined as that this third bracket in x in third bracket denote the largest integer less than or equal to x. Okay, so let me give you some examples. Suppose if I have to evaluate, say, greatest integer of 1.69. okay, so here you have this number line. On number line you will have this point 1.69. Here you will have 1, 0, minus 1, minus 2 and so on. So there are many integers which are less than this number 1.69, right? Now which integer is largest among these integers? This number 1. So this means greatest integer of 1.69, this will be 1. Okay, greatest integer simply means an integer just less than this integer. If I write minus 2.6, so what should be the greatest integer? This is our number line, minus 2 is here, say minus 3 is somewhere here, this point will be minus 2.6. So an integer which is just less than this number is minus 3. So this means greatest integer of minus 2.6, this will be minus 3. So if you want to write the definition of this greatest integer of x, greatest integer of x will be 0 if x is from 0 to 1. Okay, we have equality at 0 because when x is 0, greatest integer will be 0. For any integer, suppose if I write greatest integer of 2, so an integer just less than or equal to, so this 2 is itself an integer, so this will give us 2. But if you have 1.999, then this will become 1. Okay, so this function greatest integer of x, this will be defined in this manner. This is 0 when x is from 0 to 1. Okay, if you have any number which is from 0 to 1, this is your number line. You have 0 here, 1 here, 2 here and so on. So if I take any number between 0 and 1, then what will be the greatest integer? 0. And the moment you reach 1 or cross 1, okay, the moment the value of x is greater than or equal to 1 up to 2, okay, just less than 2, then the greatest integer will be this 1. Similarly, if x is between 2 to 3, equality at 2, then this value will be 2 and so on. So this is how we define this function greatest integer of x. So now the question was, we had to evaluate the value of this integral, integration 0.25 to 1.25 f of x is x minus greatest integer of x dx. We had to evaluate the value of this integral. Now you can see that you cannot integrate that as long as you have that greatest integer function. So first we have to get rid of that. Now for that you can see that this greatest integer function will change its definition at all integral points. Before 1 you will have this value 0. After 1 you will have this value 1. After 2 you will have this value 2. So we can write this integral as integration 0.25 to 1. Okay, we have to break this integral at integers. So there is only one integer between these two. So 0.25 to 1 and then 1 to 1.25 x minus greatest integer of x. Right? So now this will be 0.25 to 1. When x is from 0.25 to 1, greatest integer of x will be 0. And when x is from 1 to 1.25, this will be 1. So now you will get x dx plus 1 to 1.25 x minus 1 dx. Integration of x will be x square by 2, limit from 0.25 to 1. This will be x minus 1 square by 2, limit from 1 to 1. Now why I am writing in this manner? The integral can also be written in the form of x square by 2 minus x. But if I write in this manner, if I substitute lower limit, I will get 0. So this will reduce our calculation. 1 by 2 minus 0.25 square by 2 plus 1.25 minus 1. So 0.25 square by 2. If I place 1, I will get 0. These two will cancel. 1.2 is nothing but 0.5. So this means the value of this integral will be 0.5. Okay, so these are very simple problem once you know the meaning of these type of function. Okay, this function is called greatest integer function. And there is another function which is used frequently, that is fractional part function. Okay, fractional part function is represented by this second bracket, and this is nothing but x minus greatest integer of x. See, any number can be written as some integer plus some fraction. Okay, you can always write a number x in the form of integral part of x plus a fractional part of x. Okay, for example, suppose if I have this number 2.5, so I can write this as 2 plus 0.5. So 2 is the integral part of this function, 0.5 is the fractional part. If you have a number say minus 2.5, then you can write this as minus 3 plus 0.5. So minus 3 is the integral part, plus 0.5 is fractional part. Remember that fractional part is always positive. Okay, this fractional part of x, this will be always between 0 to 1. It is never 1. Slightly less than 1 and always greater than or equal to 0. Okay, so these two functions you should know. One is this greatest integer function. In short, sometimes it is also written as GIF, but every time this will be mentioned, okay, that this third bracket represents greatest integer function, and similarly this second bracket represents fractional part function. So this was one question from GATE 2018. Now we can see some other property. Till now we have discussed 3 properties of definite integral. Now we have to discuss the remaining 4 properties. Okay, so till now we have discussed first three properties of definite integral. The fourth property is integration a to b fx dx is integration a to b f of a plus b minus x dx. Okay, you can replace this a by sum of upper and lower limit minus x, and still the value of definite integral will not change. Now it is very easy to prove this result. If you see this right hand side is integration a to b f of a plus b minus x dx. Okay, now if I want to get this left hand side from here, the substitution that you need to do is a plus b minus x, this equals to t. Okay, in place of a plus b minus x I will write t. So this means dt will be minus dx, because these two are constant, derivative will be 0. Also, when we are changing from one variable to another, we have to take care of these limits also. These are the values of x. Okay, x is from a to b. Now if we want to write this integral in the form of t, we also need to calculate the value of t when x is a and x is b. So when x is a, the value of t will be, this is your expression for t. So when x is a, the value of t will be a plus b minus a and a will cancel, so this will give us t equals to b. Okay, now second case, when x is b, the value of t will be a plus b minus b. Now these two will cancel and this will give us t equals to a. So we can write this integral as integration f of a plus b minus x dx. So this becomes t, dx is minus dt. When x is a, the value of t is b. When x is b, the value of t is a. So this can be written as, if we change the integral, we will get additional minus sign. So this will give us a to b f of t dt. And our first property was whether the variable is t or x, this will not change the definite integral, which was, and this was our left hand side. So as you can see that these two integrals are same, a to b fx dx and a to b f of a plus b minus x dx. Also in some cases, suppose if you have 0 to a fx dx, so this can be written as 0 to a f of a minus x dx. Okay, this will be the integral. So now we are going to see one problem based on this. In fact, we'll see two problems based on this fourth property. So our first question will be integration pi by 6 to pi by 3 root over sin x by root over sin x plus root over cos x dx. Okay, this will be our first question. So this is very standard question. I mean, in every book on calculus you will find these type of problems based on this fourth property. So here if you add the upper and lower limit, okay, we can write that x goes to sum of these two limits minus x. Now this is nothing but pi by 2. Okay, so in place of x you can write pi by 2 minus x. So this integral will give us integration, limit will remain same. In numerator, if you replace x by pi by 2 minus x, we all know that sin pi by 2 minus x is cos x. Here also if you replace x by pi by 2 minus x, you will get cos x, and this cos x will become sin x dx. Now for this type of problem, this is a standard process. these two integrals are exactly same, and you can see that they have the same denominator, root over sine plus root over cos. So if I add these two, then this will give us 2i equals to integration pi by 6 to pi by 3. This root cos plus root sine can be taken as LCM. So from here you will get root sine x, and from this second equation you will get root cos x dx. These two will cancel, you will get 1 here. Integration of dx is x, limit is from pi by 6 to pi by 3. This will be, difference of these two will be pi by 6, so which means integral I will be pi by 12. So this will be the answer for our given problem. Now there is one standard result which you can use for evaluating these type of integrals. So the result is something like this. Suppose if I have this integral, say integration. Okay, so now there is an important result based on this fourth property that we had just learned. This fourth property was integration a to b fx dx is integration a to b f of a plus b minus x dx. Okay, we can replace this x by a plus b minus x, and still the value of this definite integral will remain same. So if I have to evaluate this integral, say integration a to b some function of x divided by the same function of x plus f of a plus b minus x dx. Whenever you see any integral in this form, you have fx here, and f of a plus b minus x here, then you can directly write that the value of this integral will be b minus a by 2. Okay, you can derive this formula using the sequence of steps that we had used in solving our previous problem. Okay, so this is an important result based on this fourth property, and if you know this result, then you don't need to solve these type of problem. You can directly write that answer will be b minus a by 2. Remember that you have fx here, and f of a plus b minus x here. For example, if I have this problem, then here you can easily see that if I write fx equals to log of x square, then this will be fx, and f of a plus b minus x. A is 2, b is 4, so this will be f of 6 minus x, and this will be nothing but log of 6 minus x. Okay, so as you can see that this integral is of this form where fx is log x square. So you can directly write that the value of this integral will be b minus a by 2. b is 4, a is 2, so 4 minus 2 by 2, which will give us 1. So this will be the value of this integral. Okay, so this was our first problem. The second one is, this question was asked in GATE 2018. So the problem is we have to find the value of this integral 0 to pi x cos square x dx. Now here either you can integrate this using UV formula, or you can simplify this. You can write this as integration 0 to pi, and in place of x you can write pi minus x cos square pi minus x dx. Okay, now this will give us, we all know that cos pi minus x, this is minus cos x, right? And sin pi minus x, this is plus sin x. So here we need to use this first formula. Cos pi minus x will be minus cos x. So I can write this integral as 0 to pi minus x. This will give us minus cos x, and we have to square, so we'll get cos square x. Okay, so now we will get 0 to pi cos square x dx minus integration 0 to pi x cos square x dx. Now if you see this carefully, this is nothing but our given integral I. So now we have obtained this relation. I is this integral minus I. So you can write 2i will be 0 to pi cos square x dx, right? So now we have to integrate this cos square x. So in order to integrate cos square x, we can write this as 1 plus cos 2x by 2 dx. Now again remember these two formula. Sin square x is 1 minus cos 2x by 2, and cos square x is 1 plus cos 2x by 2. So here if I use this second formula, cos square x will be 1 plus cos 2x by 2. So this will give us pi by 2. Integration of 1 is x, integration of cos 2x will be sin 2x by 2, limit from 0 to pi. Now if you substitute the limits, then you will get pi by 2 x, so this will become pi, sin 2 pi will be 0, and if you place 0, these two terms will become 0. So this will give you pi square by 2. Now remember that this is the value of 2 times given integral. Okay, so therefore integral I will be pi square by 4. So this will be the correct answer. The value of this integral will be pi square by 4. So this was our fourth property. Now we have to learn 3 other properties of definite integrals. Okay, so now we have these 3 problems based on our fifth property, which was for odd and even function. So the property was that the value of integral from minus a to a fx dx, this will be either 0 or 2 times 0 to a fx dx, depending on whether fx is odd function or it is even function. Okay, if it is even, then 2 times 0 to a. If it is odd function, then integral will be 0. So whenever you see that limit is from minus a to a, then try to think whether this property is odd function, whether this function is odd function or even function. So in the first example, you can see that fx is sin to the power 11x cos to the power 22x. If I replace x by minus x, okay, so I will get sine of minus x, which is nothing but minus sin x, and cos of minus x, which is cos x, right? We all know that sine minus x is minus sin x and cos minus x is plus cos x. Okay, so this is our f of minus x. Now you have minus 1 odd power, so this will be minus sine to the power 11x cos to the power 22x, right? You have minus 1 raised to the power odd number, so this will give you minus sign, and this is nothing but minus f of x. Now once you have obtained that f of minus x is minus f of x, this integral becomes 0, because limit is from minus a to a, and this function is an odd function. So since it is an odd function, the value of this integral will be 0. So for the first part of the problem, the answer is 0. The second problem is integration minus pi by 4 to pi by 4 sin square x dx. Now as you can see that this sin square x is even function, sin x is odd function, but if you replace x by minus x, then you can see that you will get minus sin x raised to the power 2. Now since you have even power, minus 1 square will become plus 1. So f of minus x will be f of x for this function sin square x. So you can write this integral as 2 times 0 to pi by 4 sin square x dx. This will be integration 0 to pi by 4, 2 sin square x is 1 minus cos 2x, right? Now integral of this will be x minus sin 2x by 2, limit is from 0 to pi by 4. So this will be pi by 4 minus, if I place pi by 4 here, sin pi by 2 will be sin 91, so this will be 1 by 2, and if you place 0, then you will get 0. So this will be the value of this definite integral. Okay, so answer to the first part of the problem is 0. For the second part of the problem, this will be pi by 4 minus 1 by 2. Okay, so this was our first problem. The second one is, this is very interesting question. This was first asked in IIT JEE in early 90s, and then the same problem was repeated in GATE 2014 in mechanical. So the question is, we have to evaluate this limit. Now if you see here, this is here the limit is not from minus a to plus a, right? So but I have written this question in this category because after doing some substitution, okay, we'll see what is that substitution, we will get that form. So what should be the substitution here? So you can see that you have x minus 1 everywhere. So this means in place of x minus 1 you should write t, and this will mean that dx will become dt. You also have to change the limits accordingly. These are the values of x. So when x is 0, t is minus 1. When x is 2, the value of t will be plus 1. So now you can write this integral as integration minus 1 to 1 t square sin t by t square plus cos t dt. Now if your function f of t is t square sin t by t square plus cos t, then you can easily see that f of minus t will be minus t square sin of minus t by minus t square plus cos of minus t. Now we all know that cos minus t is cos t, sin minus t is minus sin t, minus t square, so this will become plus t square. So finally you can see that you will get this function, right? Now since this is nothing but f of minus t, the given function f of t is an odd function and the limit is from minus a to plus a. So without doing any calculation, using that fifth property, you can tell that the value of this integral will be 0. The reason is you have minus a to a f of t dt, and this f of t is an odd function. Okay, so this was our second problem. The third problem is an interesting one. Here first we have to see the given function is neither odd function nor even function. So, but the limit is from minus a to plus a. So see how we are going to solve that problem. In this third problem, we have to evaluate this integral minus 2 to 2 x cube cos x by 2 plus 1 by 2 into root over 4 minus x square dx. Okay, we have this integral. So here you can write this function as minus 2 to 2 x cube cos x by 2 root over 4 minus x square dx plus minus 2 to 2 root over 4 minus x square dx, right? So now if you see this first function x cube, an odd function, even function, x square here, so this is also even function. So here if you replace x by minus x, you can see that you will get one minus sign here and these two functions will remain same. So this means this function is an odd function. Okay, for this particular function you can verify this on your own. F of minus x will be minus f of x. Okay, since f of minus x is minus f of x and limit is from minus a to plus a, this integral will become 0. For the second one, here if you see carefully, f of minus x is same as f of x because you have x square here. If you replace x by minus x, you will get the same function. So now you can write this integral as 1 by 2 constant, and using that property this will become 2 times 0 to a fx dx. This will cancel, 0 to 2 root over a square minus x square dx. Now you can see that this was our problem. Okay, you can see that how we have simplified this question. Actual problem was this one, but after 2 steps you can see that the question was evaluate this integral. Okay, so now we all know the formula for this one, a square minus x square dx. This is x into root over a square minus x square by 2 plus a square by 2 into sine inverse x by a, and this has to be evaluated at x equals to 2 and then 0. So if I place 2 here, 2 square minus 2 square will be 0. From here you will get 2 sine inverse 2 by 2 is 1 minus, if you place 0 you will get 0 here, sine inverse 0 is also 0, so this will give us 0. 2 into sine inverse 1 is always pi by 2, 2 and 2 will cancel, this will give us pi. So for this third problem the answer will be pi. Okay, now this was very popular question on YouTube. Okay, this question was written there in a this question was very popular on YouTube, and it was also reported in a newspaper, in a Chinese newspaper. The question was that this problem was written in a cafe, and the answer to this problem was the password of the Wi-Fi there. Okay, first 8 digits. So the answer will be pi, and now you can calculate the value of pi using calculator. So this will be the this is how we will solve this problem. First we have separated this, and then we have evaluated the integral at -2 and +2. Then we have solved this integral, and finally our answer is pi. So this was all about our fifth property. Next we have to learn two other properties of definite integrals. Okay, so now we have these two properties, 6 and 7. So property number 6 is integration 0 to 2a fx dx. This will be 0 if f of 2a minus x is equal to minus f of x. Okay, and this will be 2 times integration 0 to a fx dx. Remember that our original integral is 0 to 2a, so this you can write as 2 times 0 to a. This is half of this limit, so 2 times 0 to a fx dx if f of 2a minus x is equal to f of x. Okay, so for example, suppose if I have this integral, say 0 to pi sin x dx. So if you compare with this standard function, then fx is sin x, and f of 2a minus x, this will be f of pi minus x, which is sin of pi minus x, and sin pi minus x is simply sin x, right? So here f of 2a minus x is equal to f of x. So this means you can write this integral as 2 times 0 to a. Now 2a was pi, so a will be pi by 2, so 2 times 0 to pi by 2 sin x dx. Okay, and suppose if you had this integral, say 0 to pi cos x dx. So now here if you see this function, fx is cos x, and in place of 2a now you have this function, this number pi. So we can write this integral as, so now we can write f of 2a minus x, this will be cos of pi minus x, which is minus cos x, and this is nothing but minus f of x. So for this particular function cos x, f of 2a minus x is minus f of x, and therefore the value of this integral will be 0. Okay, so this is again an important property. 0 to 2a fx dx, this will be 0 if f of 2a minus x is minus fx, and this will be 2 times 0 to a fx dx if f of 2a minus x is f of x. We are not going into the details of this, that why this is true. You can understand this simply that if f of 2a minus x is f of x, this means fx is symmetric about, okay, this function is symmetric about this line x equals to a. Okay, these concepts are taught for IIT JEE in class 12. So if this f of 2a minus x is equal to f of x, then it means the graph of this function will be symmetric about this line x equals to a. So this means if the graph is symmetric about the line, say we are evaluating 0 to 2a. Suppose if this is the line x equals to a, this point is 0, this point is 2a, then 0 to 2a will mean this total area. Okay, so if the graph is symmetric about this line, then this total area can be written as 2 times area from 0 to a. Okay, so therefore this will become 2 times 0 to a fx dx, and if this condition is satisfied, and this means the graph is symmetric about this point a0. Okay, so in that case the area above the x-axis and below x-axis will be same, and you will get 0. Okay, as we did in our fifth property. So this formula you have to remember ultimately. Okay, these are the details which are not required for GATE exam. Simply remember this formula. If f of 2a minus x is minus f of x, integral will be 0. If f of 2a minus x is f of x, then integral will be 2 times 0 to a fx dx. So this was our sixth property, and the last one is, this is related with periodic function. Okay, periodic function simply means that the graph of that particular function will repeat after a definite interval. Okay, if this condition is satisfied, then list positive value of t is called period. We have seen some standard functions. Suppose if we have y equals to mod of sin x, we have seen what was the graph of this function, right? this will be the graph of this function y equals to mod sin x. Okay, we had talked about this function in detail in our topic graphical transformation. So this was the graph of y equals to mod sin x. Now as you can see that this graph between 0 to pi is exactly same as graph between pi to 2 pi, which is same as the graph between 2 pi to 3 pi. So this mod sin x is a periodic function, and what is the period here? Here the period will be pi, because the graph is repeating itself after every pi. So here the formula is that this integral from 0 to n times t fx dx, remember that n is some positive integer, okay, only then this formula will be valid. So 0 to n times t fx dx, this will be n into 0 to t fx dx. So, and if you see the graph of this function, if you see the graphical explanation, then this thing is only obvious. Suppose if I had to evaluate integration 0 to say 3 pi mod sin x dx. So what is the meaning of this? This means we need to calculate the area from 0 to 3 pi under this curve y equals to mod sin x. Okay, this was graph of y equals to mod sin x. So you can clearly see that area between 0 to pi will be same as the area between pi to 2 pi. So we can write this integral as 3 times integration 0 to pi mod sin x dx. Okay, area from 0 to 3 pi will be 3 times area from 0 to pi. Okay, so this was our 7th property. Now we'll take one problem based on this definite integral, and then we will move to area under curve. Okay, so now before attempting that problem on definite integral, we have to know one important formula called Wallis formula. So here suppose if I have to find the value of this integral 0 to pi by 2 sine to the power nx dx. So this integral will be 0 to pi by 2 cos to the power nx dx, and the value of this integral will depend on this n. Okay, n will be some integer, so it might be an even number or odd number. So if n is an odd number, n is odd, then you will have this first formula, and if n is even, then you will have this second formula. So if n is odd number, then the formula will be, the value of this integral will be n minus 1, n minus 3, n minus 5 and so on. Now if n is odd, then remember that this is sequence of even numbers. N minus 1 will be even, this one is even. So 4, 2, and this divided by, in a denominator you will have n, n minus 2, n minus 4 and so on. Now this is sequence of odd numbers, so you will have 3 here, 1 here. So this is the formula when n is odd number. Start with n minus 1, keep on subtracting 2 up to you reach this point 2, and in denominator also start with n, keep on subtracting 2. When n is even number, then the formula will remain same, n minus 1, n minus 3, n minus 5 and so on. But since n is even, now this is sequence of odd numbers. So this means here you will get 3, here you will get 1, and this divided by, in denominator n, n minus 2, n minus 4, so on, sequence of even numbers, so 4, 2, and when n is even, you will get this additional term pi by 2. You have to multiply this expression by pi by 2. So this formula is very, very important if you want to evaluate the definite integral of this form 0 to pi by 2, either sine nx or cos to the power nx. Okay, now we can attempt these two problems. So for the first one, n is odd number, right? N is 7. So here we have to use the first formula. So the value of this integral using that formula will be 7 minus 1, keep on subtracting 2, in denominator 7, and then keep on subtracting 2. So this will be the value of integral. Okay, since n is odd number, this will be the value of integral. And the second one is n is even number, right? Here we have n equals to 10. So the value of that second integral will be n minus 1, so 9, then 7, then 5, 3, 1, and in denominator start with 10, 10, 8, 6, 4, 2, and then multiply by pi by 2. So this formula you have to remember, and if you know this formula, then you can easily evaluate these type of integrals. So now we will talk about area under curve.